Every single time you click a link, stream a show, or send a message, it's all traveling through a network that was actually born from the fear of a nuclear war. Pretty wild, right? Today, we're going to pull back the curtain and look at the blueprint of the internet. We'll see how it went from a top secret military project to, well, the global nervous system of our modern world. So let's dive in. Okay, get this. We're talking over 5 billion people online today. That is just a staggering number. This one network, it powers our economies, it shapes our friendships, it basically runs our entire lives. But the crazy part? Its origin story has nothing to do with connecting people. Nope. It all started with the threat of being completely wiped out. All right, so let's rewind. It all kicked off not because someone wanted to share cat photos, but because they were terrified of disconnection. See, during the Cold War, the US military had this nightmare scenario. What if a single nuclear strike took out their main communication hub? It would completely decapitate their command and control. They needed a network that could survive, well, pretty much anything. And this was their absolutely radical solution. On the left, you've got the old way of doing things, a centralized system. Think of it like a spider web with a big spider in the middle. You take out the center, and the whole thing just collapses. But on the right, that was their genius idea, a decentralized network. No center, no single point of failure, just tons and tons of different paths. This way, a message could always find a way to get through. It wasn't just a communication network, it was a survival mechanism. So, from that brilliant survival-focused idea, ARPANET was born. You can think of it as the great-great-granddaddy of the internet we use today. Back in 1969, they picked 4 universities to be the very first nodes on this brand new experimental network. They were laying the first few bricks for what would become, well, everything. And the network's grand debut? Oh, it was a little less than grand. On October 29, 1969, a programmer sat down to send the first message from UCLA to Stanford. He was just trying to type log in. Simple, right? Well, he typed L, then he typed O, and the whole system crashed. That's right. The first message ever sent across the internet was just OL, a tiny broken word that, believe it or not, would end up changing the entire world. So, you're probably wondering, how did this thing actually work? What was the magic behind it? Well, the secret sauce was a technology called packet switching, and the idea is actually pretty simple. Instead of trying to send a huge file like a giant photo all in one big clunky piece, the network would chop it up into tiny little chunks or packets. And this right here is the internet's superpower. It's like, imagine you're trying to mail a huge book. Instead of putting it in one giant box that could get lost, you tear out every page, put each one in its own envelope, and mail them all separately. Each page, or packet, travels on its own, finding the fastest, least congested route. Then, once they all get to their destination, they're put back together in the right order. It sounds simple, but this idea is exactly what makes the internet so incredibly fast, efficient, and so resilient. Okay, so ARPANET was growing and other networks were popping up too, but there was a problem. They all spoke different languages. They couldn't talk to each other, so they needed a common language, a kind of universal translator for computers. That language became TCP/IP, and when it was officially adopted in 1983, it was a game changer. It stitched all these separate networks together into one single unified internet. In fact, a lot of people say that day, January 1st, 1983, is the real birthday of the internet we all use.
So, at this point, the internet existed, right? But for years, it was this really complex, text-only playground for scientists and military folks. You had to know all these weird commands. It wasn't user-friendly at all. The next giant leap, then, was to figure out how to make it accessible and, actually useful for everybody else.
And that leap? It pretty much came from one guy, a British scientist named Tim Berners-Lee. In the early 1990s, he created this incredibly powerful toolkit. He invented HTML, which is the basic language for making web pages. He came up with URLs, which are just the addresses for finding those pages. And he created HTTP, the protocol that lets you actually get the pages. With those key pieces, he basically gave the internet a friendly face, turning it from a confusing text maze into the visual, clickable World Wide Web. And that's when the floodgates just burst open. You had the famous browser wars between Netscape Navigator and Internet Explorer, which was this fierce competition that pushed innovation at a ridiculous speed. All of a sudden, the web wasn't just for nerds and scientists anymore. It was for everyone. The internet had officially escaped the lab and was exploding into popular culture.
So that's the whirlwind history tour. But what's actually happening right now, under the hood, as you're watching this? Let's take a quick, simplified peek at the actual machinery that's making all this happen.
I mean, it all happens faster than you can blink. First, your device, your phone, your computer, whatever, that's the client, and it sends out a request. Then, a system called DNS acts like a giant address book to find where that request needs to go. Next, routers, which are basically the traffic cops of the internet, guide all those little data packets to the right server. And finally, that server sends all the data you wanted right back to your screen.
Okay, let's zoom in on that DNS part for a second, because it's super important. Think of the domain name system as the internet's phone book. It's that simple. We type in a human-friendly name, like youtube.com, because who's going to remember a long string of numbers? But computers, they only speak in numbers, these long IP addresses. DNS is the magic that does that translation for us, instantly, billions and billions of times a day.
All right, now here's a fact that just blows most people's minds. How does all this data get from, say, America to Europe? You're probably thinking satellites, right? Floating around in space? Nope. The reality is way, way cooler. A staggering 99% of all international data travels through a hidden network of massive physical fiber-optic cables lying on the bottom of the ocean. So where does all this stuff actually live? Well, it lives in data centers. And these aren't some abstract clouds. They are gigantic, real-world buildings, basically the physical brains of the internet. They're just packed to the rafters with servers, run by companies like Google, Amazon, you name it. They store literally everything. All the websites, every YouTube video, your social media feeds, your emails, all of it. When you think about it, the internet's evolution has just been breathtakingly fast. I mean, we went from a handful of connected computers to a global digital universe in just a couple of decades. But here's the thing, the story is nowhere near finished. So, where are we going next? Well, the next massive wave is already building. We're talking about things like AI that can manage network traffic on its own, a quantum internet that could offer truly unbreakable security, 6G connectivity so fast and seamless it just feels invisible. We're even on the cusp of things like brain-computer interfaces. I mean, if you think the last 50 years were a big deal, the next chapter could completely redefine what it even means to be connected. So there you have it, the incredible journey of the internet. From a Cold War defense project built to survive Armageddon, all the way to this global platform for connection, business, and creativity that we all live on. It has, without a doubt, become one of the most powerful inventions in human history. And that just leaves one big question. What comes next?